This first part of the video is going to seem a little different because I found out part of the way during class that my screen actually wasn't recording. So I'm going to cover what I had covered before I started recording, and then it'll jump into what the rest of the class was doing. So we actually started with, this class is working with solving quadratic equations. So let's get down the definition of a quadratic equation. So our formal definition is a quadratic equation is a second order polynomial equation in a second variable. So let's break this definition down because it seems like there's a lot of big words, but we actually know what most of these mean. So second order, you can also think about as being second degree, is what we actually learned last week. If a term has a second degree, it's saying it has a square on it, where something's a third degree, it has a cube on it. So this would be something like x squared. So it just means that in this equation, there's like an x squared or a k squared or a q squared. Polynomial means, of course, there's multiple terms. And we have a single variable that we are trying to solve for. So a quadratic equation might look like, this is going to be the normal form that you see for a quadratic equation. Now, everything is in the order it should be, with the higher squares going first, followed by just the one variable, followed by anything else. And you want it always to equal 0. So if you're given terms and it doesn't equal 0, just move things around, move everything over to the other side, and then because there's nothing over here, it's going to be equal to 0. And of course, you want to make sure it's in the right order, and it'll make everything nice to solve. So today we're going to be learning 4 different ways of solving these kind of equations. So the first way is going to be by factoring. So this is still a quadratic equation even though we only have 2 terms. That's alright. We have our second order term, which makes it still a quadratic equation. Now we're going to solve by factoring. So we're going to start in this case by taking out anything that is the same from both of them. So I see that there's a 3 that I can take out from both of them, and there's also an x, just one x that I can take out. So if I take out a 3x, so I'm essentially dividing this by 3x. What's left over is 1x. Then if I divide 6x by 3x, I'm left with 2. So I've broken down this equation into 3x is multiplied by x plus 2. And the trick is, I want to figure out what x could be, so this whole thing will go to 0. Well, 0 is a pretty special number where if I have one part that equals 0, then it doesn't matter what everything else is because anything times 0 is 0. So if I can make 3x equal 0, then it doesn't matter what this equals. Or if I can make this part equal 0, it won't matter what this stuff up front is. So I'm essentially looking for the number that can make 3x go to 0 and the number that can make x plus 2 go to 0. Now I know you're thinking this might end up with 2 terms, and that's okay. Quadratic equations tend to give you I know you're looking and seeing this might be that there's 2 answers, and that's okay. Quadratic equations tend to give you 2 answers. So here I'm looking at, well, what times 3 give me 0? Of course, 0. So one of the answers is 0. And over here, what plus 2 gives me 0? Well, negative 2 does. So x can equal either 0 or negative 2. It's not a combination of those 2 numbers. It's either 0 or a negative 2. So if I wanted to check these, I could just put them back in my equation and see if they work. So if I put 0 into this equation, well, anything times 0 gives me 0, anything times 0 gives me 0. So this one works out. Then let's check negative 2. Negative 2 is squared is 4. Well, that's 12 plus a negative 12. Yeah, that equals 0. So you can see independently both of these equations, you can see independently both of these numbers work. And so that's our 2 answers for this equation. Let's take a look at another example. So here we have our quadratic equation, a polynomial that with 3 terms. So our factoring is going to be a little different. So you're going to get a mini lesson right now on how to factor things that look like this. So we are essentially looking for the 2 sets that get us to here. So you have to remember back to, I think it was last week when we were talking about how to multiply expressions and how it would get you to this. So thinking back to last week when we did that whole box thing, and it was like x plus 2 and x plus 1, and you multiply them together. That's what essentially we're going backwards to. We're trying to figure out what those two things were that multiplied together to get to here. So in this case, the way this works is we need two numbers that when multiplied together give you 27, because when we multiplied them together they gave us 27 in this box. And then we need two numbers that when added give us -12. Now we need the same set of numbers, because that's going to tell us what goes here to give us these two boxes that add up to that -12x. So thinking about my factors of 27, I can have 1 and 27, I can have 3 and 9, and I think that's actually it. So which one of these can we add together to get 12? Well, 3 and 9 can add together to get 12. Oh, but it's -12. Oh, what if they were both negative? And that actually would work. So a -3 times a -9 gives us a positive 27, and a -3 plus a -9 gives us that -12. So that's going to tell us that if I were to factor this, I'm essentially undistributing everything, unfoiling it, I get that it's an x minus 3 and an x minus 9. And if you have these switched, you have x minus 9 first or an x minus 3 last, it won't matter. So we factored here to get to here. So we went backwards and figured out what it was that we multiplied together to get to here. So now it's going back to the same thing that you saw before, where we're trying to figure out what can make each part go to 0. So what can make x minus 3 go to 0, because that'll make the whole thing multiplied become 0. And what can make x minus 9 equal 0? Well, if I want x minus 3 to equal 0, what minus 3 gives you 0? Positive 3, so x can be positive 3. And what would make x minus 9 equal 0? Well, positive 9. So x equals positive 9. And some of you will get pretty good where you can see that right away without doing this stuff. So you would look at that and be like, oh, if I put a 9 there, it goes to 0, and then that's my answer. So your two answers that make this equation equal 0, that work in this equation, is 3 and 9. All right, let's go ahead and take a look at 2 first. So 2 was probably the simplest one, and it's kind of already broken down for you. So if I wanted to break it down further, I need to think, okay, there's one number that needs to be just what m could be to equal 0, and then another one where m minus 3 equals 0. So m equals 0, that is the actual answer. So one of the solutions to m would be 0. What about m minus 3? Yeah, 3. So remember, you should always have two answers. So in this case, m could equal 0 or 3. And you can either list it like that or m equals 0 or 3. Yeah?
So I plugged it in, I plugged 0 in, and then so I'll distribute it.
You don't have to.
Oh, yeah.
Right?
0 times 0. Oh.
Because 0 times anything gives us 0.
And then 3 minus.
Because it's going to be 0 times minus 3, which still is 0.
And then if you plug in the 3, you get 3. Because it's 3 minus 3, it gives you 3 to 0,
Which still gives us 0. Osai?
You could also have a 3 and a 1. 3 minus 3.
Well, yeah, 3 was one of the answers, but 1 won't work. So Osai is wondering if 1 could work. Well, let's just try it. If I put in 1 for m, 1, and then 1 minus 3.
I thought you'd have two different answers.
But they both have to work independently. It's not a combination of these two together. It's m in one case could be 0, or m in another case could be 3, not together. So 1 actually wouldn't work. All right, let's look at 4. Okay. 4 was also nice because it already was a factored trinomial for you, so you essentially just needed to figure out, all right, I need something that n plus 2 would give me 0. So what plus 2 gives us 0? Joey? -2. And this one was a little tricky, but if you remember all the stuff we've learned in class, how do we solve for n? What do we do? Mimi? Subtract 5. So I have 2n equals a negative 5. Then what? Divide by 2. So, yes, this is a fraction, but it's not like it's that hard to write negative 5 over 2. Joey?
We also write it as a decimal.
You can write it as a decimal, but honestly, that's another step to transfer that into a decimal. So it's like you might as well just leave it as that.
So then can equal 2 or
Yeah, so if you want to put it as a decimal or you want to turn it into a mixed number, but your math teachers in high school should accept that. Unless they specifically say in the instructions leave as a decimal to whatever places, but they probably won't. Okay, let's look at 6. All right, so 6 was a little complicated. First of all, it wasn't even in the order we want. Ryan, do you need to leave? Right, because this is after school, so I'm not dealing with discipline problems right now. I'm over it. So we need to move all this junk to the other side. They're both negative, so how do we move them? Adding them. So we're going to add 18 to both sides, and we're going to be also adding the 9n to both sides. Now, because none of them are equal, the same terms, we can't actually combine anything, so it just ends up looking like this. And this is the general form that you would want for your trinomial, with the squared first, the one variable is next, and then the one without a variable equals 0. So first thing is get it into this form. Then we need to break it down into those two sets. So remember, we need two numbers that when multiplied together will give us 18, and that when added will give us 9. So they need to multiply together to get the last number, and they need to be added together to get the middle number. So what numbers when multiplied together give us 18 and when added together give us 9? If you don't know, you can always just write down lists. Well, what multiplied give us 18? Well, you have 18 and 1, 6 and 3, 9 and 2, and then you kind of look at that. When I add any of those together, which ones add to 9? 6 and 3. And they both can be positive, so they're both going to be plus 6, plus 3. And again, it doesn't matter which order they go in. It could be plus 3, plus 6. It doesn't matter. Yeah?
When do you know how to use that kind of word? When do you know?
This part? You know to do this when you're trying to figure out what the factors were. So if you're solving by factoring, you're doing this.
Okay. We didn't do it.
You didn't because it wasn't in this form. So when it's in this form, but you're trying to break it into this form, you're using this. So we're not done. Now we need to find out what can turn this into 0 and what can turn this into 0. Joey?
For the first one, if n is negative 6.
Absolutely. Negative 6 plus 6 gives me 0. And who can tell me the next one? Caitlin?
Negative 3.
Negative 3. Negative 3 plus 3 gives me 0. So n is equaling negative 3 and negative 6. And that's it. How do we feel with factoring? It's a little weird. And I know it's very unfamiliar, especially from going from here to here. It's brand new to you. But it's just one of the 4 ways you can solve these. Yes?
Where you're taking the placement test, is it going to be saying, like, now you're going to be doing quadratic equations? Or, like, how is it going to be?
I think it'll say solve the following quadratic equation. I don't think it'll say that you have to solve by factoring or solve by whatever. I don't think it should. It'll probably just say solve this quadratic equation, or it'll give you something like this and say solve for n. And you can do any method you want. Yeah, which would be like this, and then it's just, you get these two. Yeah. All right. Where's my notes? There's my notes. Next one is by grouping. This one is probably my least favorite because it just feels like a lot of extra steps. But it works when you have a number in front of your square. Something like that. Because obviously factoring when you have a number in front is going to be a little weird. So you can always do this instead. So there's a lot of steps. So let's go through this as fairly slowly as we need to. So one's going to be, you're going to multiply your first and your last term, the numbers in the term. So in this case, that's 5 and 2. The next thing is you're going to find the factors of that number you just found, so in our case 10, that are going to add to our middle term. So we need to find the factors of 10 that add to 11.
10 and 1.
10 and 1.
What if the middle number had like an X? Oh, it does.
It does. We're just looking at the numbers.
Oh, and if it was like X plus, instead of a 2 would be an X, how would you multiply it?
If this was an X,
Uh-huh.
well then you could combine it with this one,
Oh, and then it would be.
and then you could solve it by whatever kind of you want to solve it. Anyways, Isaac? Yes, you're right. That should be an addition symbol. Thank you. Thinking of how to describe. So we're going to change the 11x into 10x plus 1x.
I don't think step 2 is necessary.
Yeah, obviously as you get good at this, you can start skipping steps. So if you think about this part as far as like the entire, we're changing the entire thing. We're changing it to be like that. So the part we changed was this middle part. Then we're just going to kind of group them together. The first two can go together. The 5x squared plus 10x can go together. And then the 1x plus 2 can go together.
Does it matter how you group them?
Well, it should be, you should have, kind of. It should be like the first two and the last two. But like if the 10x and the 1x were switched, it should be okay. Alright. It actually gets easier from here. So now we're going to factor both of these essentially sets that we made. So if I take a look at 5x squared plus 10x, what can I factor out? Just of this part. An x, what else?
And a 5.
And a 5. So I'm going to have 5x and x plus 2. And then I also need to do this one. Now this one there actually really isn't anything there. So I can just think of it as it's just x plus 2. Is there anything similar going on between those two things, Dan? Just the 2?
X plus 2.
The whole thing, this x plus 2 and x plus 2 is similar. So we're going to take it away from both parts. So if I take the x plus 2 away from 5x, what we have is we have an x plus 2, obviously being taken out. And what's left over is we have that 5x. And because I'm taking an x plus 2 away from an x plus 2, I actually have a 1 left over. So it's like the really long version of factoring.
Wait, explain that again.
Yeah. So I'm taking away an x plus 2. So if I take away the x plus 2 here, I have the 5x, right? Now if I take away an x plus 2 from an x plus 2, I actually still have a 1 left over because you can think of they're dividing by each other. And so the x plus 2 goes up front, and then that 5x and the 1 come in.
Away.
Yeah.
So it's not like I'm subtracting them, it's like I'm dividing everything. And if I have x plus 2 over x plus 2, anything over itself equals 1. Just like 5 over 5 is 1, 10 over 10 is 1.
No, but wait. Why did you get the first x plus 2?
That's what I factored out. So remember when you factor things out, so let's say I had 2x squared plus x. If I factor out that x, it doesn't go away. It's still there. So it goes out front. So same thing here. I factored out the x plus 2, but it can't go away. It goes out front.
But would it be like 4 and 2x? Because if you would add them together.
No, we don't need to add them together. We're taking them away from both things. It's not like this became a 2x. We factor out 1x from both terms. So we're factoring out one thing of x plus 2 from both of them. So it goes out
So
front.
when you.
Oh, I get it.
Okay. So now that we're at this point, kind of goes back to what we were thinking last time. So x plus 2, we need to turn that to 0. So what can x equal?
Negative 2.
-2. This one might be a little bit tougher. So you have to subtract 1, then divide by 5. Do we need to write it out so we can see it?
Yes.
Subtract the 1. 5x equals a -1. You divide. So x would equal a -1 over 5.
1/5.
-1/5. So it's -2 and -1/5 in this case. So I know that seemed really, really long, but factoring getting to here from when you have a number in front of x squared is extremely hard the other way. Because then it's a lot of guessing and checking and you never know. This way will always get you your answer. This seems easier? Okay, no problem then. I told you there's 4 different ways I'm teaching you. Whatever way you want to know, I'm going to be quizzing you on all 4, but when it comes to the actual test, if it says solve, you just solve. Doesn't matter how.
This is like.
Huh?
This is a lot of work.
I'm sorry.
Plus the 3 projects we have going on.
We have a lot of water
We
now.
have 3 projects.
All right, I'm gonna have you guys actually go back to the handout I gave you. You're gonna do a couple more from there. So you're gonna try number 5 and number 7 for this. Try 5 and number 7 this way. Okay, just 2 little ones. I'm gonna give you 5 minutes. Try those 2, 5 and 7. Go ahead.
Now I know what I did.
Oh.
Mine's in the middle.
Oh, yeah, we have to order it correctly.
You have to reorder them, remember?
Oh.
This is
Oh, in the order. I'm gonna wait until she does it.
Yeah. It's 3 times 72.
3 times 72 is 21.
216?
I'm getting. I got. In my head, I got 216. Yeah.
Hopefully you're right. Okay.
Well, I was like the best at mathematics.
in 3rd grade.
Yeah, and I still have to continue. So.
Oh,
Why do I feel like all these just do my colors? Miss Kibler? Miss Kibler? I have a question. When did you get a surplus of colors?
There's like always been one. It's just as people grab them from the cabinet and don't put them away, they just end up there.
Because last time I remember I was in your class and I accidentally left my 50 color pencils here and I never owned them again.
I don't know.
And they were Crayola.
Well, I'm sure all the ones I have are Crayola too.
Because don't you have the basic packs, the 12 one?
No, I think I've had one of the 50 ones too. The
Because I
factors.
love those colors, you know?
Oh, your factory.
So you were adding 17.
Those factors. If we break it down by 4,
54? I got 54.
Yeah, 54.
I'm getting 29.
I'm getting 54.
No, because
54?
if you ignore the 16 and it's just 200, all of them would be 50. And then if you...
You're right. I was thinking 25. Okay. Doesn't break down by. Let's see.
Yeah, those are all the possible answers.
No. This might have been a hard one to give you guys. What are my answers?
I'm gonna die.
What?
Is it 6?
I have 2.
Someone help us with the factoring of the 216. Is it 6? 8?
36.
36 and 6?
Would that work?
But that doesn't
give you
add 33.
7? 21?
Oh yeah, it does 36 times 6 does. It gives you.
Wait, what about
But it doesn't give you the 33.
Alright.
Is it 7?
Maybe.
8? What would 8 be? 8 is 27?
Oh, that would not work.
No, it wouldn't. That would
Wait,
be
why don't we
35.
just use 54 times 4? Skipper.
Huh?
Why don't we just use 54 times 4?
Because it has to combine together to get to
Oh,
negative
actually,
33.
It's 9.
Yeah,
It's
9.
9.
It's 9?
24.
9 and 24? Okay.
Yay, you figured it out.
Repeaters.
I calculated.
Yeah, that would.
Okay,
Oh, because that's
So
to
we-
multiply and add to.
because it has to add to this. So 3k squared.
Negative?
Because they have to add up to negative.
How did it get so far on land? I've never seen a progression before.
Oh, 9. Oh, we found it. Good.
What's this guy? Some help. What's the common between 24 and 72?
That would be 8.
Is it 8? Is that it?
24 times 8 times 4 is 24, and then 8 times 9 is 72.
Oh wait, but then you can take out another 3 then.
It could be 6.
What's 3 times 8?
3 times 8 is
24.
is that right? Yeah, 24.
Oh my god. 72 divided by 24.
3
Is it 3?
3.
72 divided by 4?
3. Yeah,
24.
3. If you think about it in days, it's 3. Yes, 3.
Okay. Oh, here's a trick. We need to take out a negative and change these guys. Okay, so your common is the k minus 3, and then what's left over is a 3k minus 24. So obviously one of the answers is going to be 3. The other answer is going to be 24 over 3.
Whatever.
On this part?
Whatever. I get it now. I get it. Yes, I get it. Yes, I get it. Okay.
I don't get it.
Factoring is so unfun. I hate it.
I don't get
Oh wait, can you just simplify 24 that one to
How did you get from that to that?
We were in the process of it.
Which part?
All of it.
5 to the top of the.
Okay. All right, pay attention. This is the only one I'm going to go over because this is the only one we have time to go over. Hopefully you were following my steps as I did it.
Yeah,
It's sounding like some people need to be kicked out. Okay. So hopefully you follow my steps down to number 5. Then the question arose how I got from here. So the common is k minus 3. So that's what's being factored out and comes out front. The leftovers is that 3k and that negative 24. That's where those come from. And then you do our normal thing of, well, what makes them go to 0? And we found the answers were 3 and 8. So this one was probably hard just because of the fact that they were big numbers. So I do apologize for that. When I was looking for sample ones, I was just looking for ones that were whole numbers. So I do apologize for that. Okay. Can I erase this? No? Okay. Be quick. Because we're running short on time, and I want to have enough time to sing.
Do we have to do number 7?
Okay, can I erase this?
Yeah.
Yeah.
Or is it another form?
It's another form.
I got it right. Yeah, that's I love that. Just like my hand.
That's one of the reasons why it's my favorite.
I'm just thinking of pentatonic next time.
I'm gonna die.
And we're like, oh my god, I guess I'm 6 now.
Remember, if we go over time, you have to stay. Okay, this next one, the third way is called completing a square. It's actually not too bad. When you first learn it, it's a little confusing, but it's not bad once you get a hang of it. This one's a good one that you can do if you don't have numbers in front of the x squared. So it's not a complicated one. You're right. So whenever you're solving a quadratic equation, you want to get it into this sort of form where you have the x squared, the x, and then the other one equaling 0. That's always want to be your starting point. This one, though, we're actually going to be changing it around. So whatever this last term is, you want to move it to the other side. So step 1, move last term to other side.
2, 7.
Yep, so we're going to move that 7 to the other side. Because it's negative, how am I moving it?
Adding.
Adding it. But leave a space. It's like we missed it so much we couldn't fill the hole. Math is full of tragic stories. It really is.
Could be 0 minus.
No. Just leave it. Just leave it. Because we're gonna put something back there.
Like the Y2K.
Okay. The next thing you do is you're taking the number from the middle term, so in this case 6, you're timesing it by 2 and then squaring it. So we're going to take 6. First we times it by 2, so what do we get? Oh wait, not times 2, sorry, divided by 2.
3.
Yeah, that'll keep our numbers nicer. So we're going to do 6 divided by 2, so we get 3, and then we square it, so we get 9. So you take your middle term, divide by 2, we got 3, then we take that 3 and we square it.
What happened to
Wait, why are
X?
you dividing by?
Because she said 2.
It's just a general rule that will always work.
Always like the two.
Always work. Always divide by 2, then square.
What happened to X though?
We're just dealing with the numbers that are there. We haven't actually manipulated anything. It's just telling us how to get this number that we're going to use in a second. Okay, now this is why you leave a space. So it makes this next part easier. We're going to take that 9 and we're going to add it to both sides. So our x squared plus 6x is now going to be plus 9. And on the other side we have 7 plus 9. So we haven't changed the equation, remember, because we kept things balanced. What we did to one side, we did to the other. So we haven't violated any math rules here. Yeah, we can just add 7, 9, so obviously this becomes 16. Okay. Now this is why this way is called completing the square. If I were to factor this side, you're actually going to get something that is the same. So if I were to factor this, remember I need a number that multiplies together to get to 9 and then adds together to get to 6. What number is that?
Wait, what?
What can I
3.
multiply together to get to 9 and add together to get to
3 and
6?
3.
3 and 3. So, instead of writing that, we can write it as x plus 3 squared equals 16. So this is why it's called completing the square, because you always end up with some sort of thing being
Hi,
squared.
sorry to interrupt you. We
What's
was
up?
to pick up some students at 4. You guys, is this math enrichment?
Yeah, it's
No.
over at 4:30
Oh,
though.
it's 4:30? Okay,
Yeah.
I thought you said 4. Okay, thanks a lot. We'll
Yeah.
wait.
So here we have x plus 3 being squared equals 16. Okay? So now we can just solve for x the old-fashioned way. So we need to undo squaring. How do we do that? Square root it. So I'm going to square root both sides. So, sorry, I kind of went away from my step. So step 4 was factoring.
Step 5 is square root.
Step 5 is solve for x.
Why'd you?
I know, I'm sorry, I'll move. So if we're gonna square root both sides, I get x plus 3. What's the square root of 16? 4 and negative 4. So it's plus and minus 4. Positive and negative 4. That was a bad way of writing that. Okay. What else do I need to get rid of away from x?
3.
The adding 3. How do I undo adding 3? Subtract 3. Okay. Some of your math teachers will allow you to leave your answer as it's plus and minus 4 minus 3. If you want the actual numbers, we'll just break that up. If 4 was positive and we minus 3, what's that answer? 1. If 4 was negative and I minus 3, what's that answer?
1.
Come on, guys. Negative 7. So maybe in your guys' case, if you can leave it like this, you should. So in this case, x can be either 1 or negative 4. Wow, 1 or negative 7. It's been a long day.
This is yeah, I'd rather stay in junior.
All right. Is it okay if we skip practice on this one?
Yeah,
Because we're running out of time. All right.
Who is something I want to be squared minus 4ac all divided by 2. By the formula, that's x.
By the formula.
Is this one for
This is for the song.
this one's the easiest.
This one I like.
Is it easy?
that's why you saved it for last.
That's why I always save it for last. Actually,
All of them have to be equal to except the third one.
they all, yeah. Well, the third one because you move it over. Yeah.
Kayla wants to know what time the institution is. The answer is coming up on March 4th.
Gonna ask you after class.
Will you just remember my lunch?
Okay. This one is my favorite because it will always work regardless of how disgusting the equation is. And there's a song that goes with it, which is another reason why I love it so much.
Why do you have two equations up there?
I have two equations up there because I'm going to show you what these mean. So, in the math world, whenever you see a quadratic equation, the number in front of x squared, we call a. The number in front of x, we call b. And the last number is called c. So what's a in this case?
6.
What's b?
12.
And what's c?
48.
Negative 48. The plus or minus stays with that number.
Something goes into all of them.
Now, the way this is nice, and probably because I'm an old-fashioned math person, I love formulas. So all you have to do is plug these numbers into this formula, and it'll work out. And the nice thing is, the song I'm going to teach you will make it so you will always remember this formula, even though it will look complicated.
Okay, so I'm not scared.
I learned this equation when I was also in 8th grade, because when I was taking Algebra 2.
I feel like I should be terrified.
And I have not forgotten this since because I know the song. So take a moment, write that down. X is equal to the opposite of b, so minus b, plus or minus radical, b squared minus 4ac, all divided by 2k.
Did you cover the insurance of our brains?
Quickly, we don't have much time left.
And your word just needed to
Why is it so
All right, shh. Get it written down. Come on, quickly.
I have it. Can you just put x equal to the minus?
Can I just say already?
Just. Okay. Okay. Now, remembering this is going to be hard. Okay? And they don't let you use notes on the placement test. So if you can remember this song, then you will be able to always write this. Now, the words in the song, it may not be the word choice you use. It was the way I was taught, and it kind of just goes along with the melody. If you want to remember a different way, that's totally fine. But the song goes like this. X is equal to the opposite of b, plus or minus radical, b squared minus 4ac, all divided by 2a. Okay, that's it. So you have this now, so you can practice it. We're going to practice it one time together. Stay with me. We're going to practice it one time together. So with me, following along here, following on the board. Ready? Begin. X is equal to the opposite of b, plus or minus radical, b squared minus 4ac, all divided by 2a. Yay! I got to learn the song. Okay.
I'd rather just not write it down.
Thank you, Jared. Thank you, Nick. All right, so now let's actually see how it applies when we're trying to solve. So these A's, these B's, these C's are referring to these numbers. So these are the numbers we plug into the formula, and then we just do the math. So we need to plug in the opposite of B, so 12 is going to become negative 12. Plus minus. We have a radical sign. B squared, so we'll put it 12 squared. What's A? 6. What's C? Negative 48.
Well, I like this one.
Yeah, it's not too bad. Divided by 2 times RA. So it looks a little nasty, but it will always work. Always work, regardless of what these numbers are and how weird they are, and if they're plus or minus or big numbers, small numbers. This will always work, and that's why I like this one. So now we just need to crunch the numbers for this to find out what x equals. So first thing I notice is I know what 12 squared is. What is that? 24?
104.
Oh my goodness, people. Okay. Someone with a calculator or a big brain. 4 times 6 times negative 48.
4 times 6 is 24. 1,100.
What is it?
Negative 1,000.
52. And since it's negative, it's going to cancel out that minus sign, so it's going to become positive. What's 2 times 6? 12.
I did. Oh my gosh. We'll add those together.
Now, we need 144 plus 1,152.
1,290 something.
96.
What is it?
1,296.
296? Okay. Someone find out the square root of that.
Oh my god. If I can find the square root of
You have a calculator.
Are we allowed to have calculators?
No, but you probably want to just shoot guessing check. 36. Okay. I apologize, I'm going to work this way. I have the negative 12 plus minus 36 over 12. Okay, we're down here now.
That's gonna be cool. One.
I'm going to move up here so I have more room to work. So we have a negative 12 that in one case is going to be adding to 36, and in another case is going to be subtracting 36. So this is, again, why we always end up with two answers. So what's negative 12 plus 36? So I'm $12 in debt, then I find $36. Joey?
Then you have 24.
I have 24. $24 divided by 12.
It's 2.
2. So one of the answers is 2. That's good. Then if I do negative 12 minus 36, negative 48, divided by 12, negative 4. So there are my two answers. The formula always works.
What if there's like 4 letters? I mean 4.
Then ABCD.
This only works if it's in this form. If you have an x squared, a regular x, and then it's another term. That's it.
doesn't always well.
Well, this is a quadratic equation. This is called the quadratic formula. They go together.
Wow.
Okay.
That's
But you would be surprised how much math goes around these kind of equations.
I'm smart, I swear to God. I'm gonna keep saying that until it's true.
Okay. I'm going to be passing out your quizzes. There is going to be 2 problems of each type, so it's a total of 8. Do as much as you can. I will have the retakes up here available for any that you want to retake. And you, of course, can use your notes.